Ok, duas pessoas. Infelizmente, eu não posso falar no português. Meu português não é bom o suficiente. Esse ano a gente não tem tradutores, mas eu vai ter muitas fotos e depois você pode você vê o recordo de novo, talvez tem artigo do internet também com tradução português. Mas eu espero você pode entender um pouco. E quando eu vou falar depressa demais, fazer alguma coisa, eu entendo. So, welcome everybody. Thank you very much for coming. I'm Thorsten Grote from Germany, and I will talk a little bit about the evolution of the crypto messengers and about the new challenges that we are still facing and about how maybe Briar could be one of the solutions. So, you guys still remember that? Yeah, that's old. And these services in the beginning didn't use any crypto at all, and this is looking like this, like this schematic explanation of how Alice is talking to Bob through a server. So what started in the beginning is they introduced something called transport encryption. Yeah, so it's like encryption is a process of making the data unreadable for people who don't possess the keys for the decryption. So only the people who should read the messages can read them. So the thing with transport encryption is, it looks like this. So the connection between the server and Alice and the server and Bob is encrypted, but the server itself can decrypt or needs to decrypt the message. So the server can read everything. And this has been like this for a long time with many of the things we use. At least people snooping on this connection cannot see what's going on, but it gets decrypted in the server, which is not nice. So that's why people have come up with this end-to-end encryption. So the encryption goes through the server. It gets not decrypted at the server, but only at Bob's computer where Bob can read it. So and the two can be combined. You can have transport encryption that transport messages that are end-to-end encrypted, which is like the best thing. So this is generally what you want if you want to keep your communications private. And more and more messaging applications have adopted this, which is awesome. So and there's one problem with this, so-called man-in-the-middle attacks. So there is a man in the middle now. It's malware. So it's all end-to-end encrypted, but the people are not sure what the ends are. So the end for Alice, she thinks it's Bob, but actually it's Mallory. So she has a crypto session with Mallory, and Mallory has a crypto session with Bob, and both Bob and Alice think they are talking only to each other. But Bob in the middle can decrypt everything and then encrypts it again for Bob. So this is a problem. With GNU-PG email encryption, you usually do this by verifying the fingerprints and then trusting the key, signing each other's keys. Like, it's very complicated and not nice. So let's summarize a bit. Like, when we evaluate the communication systems, especially the messengers, we're looking primarily on end-to-end encryption. Like, today, this is like what you want. We don't want to go back. Like, there is more and more services introduced which have this now as an optional feature. Even Facebook introduced it. You can opt into this now, but other messengers have it by default. And this is what we want. Like, don't want to go back to the Stone Age anymore. So the other point is what I call authentication. Like, this essentially prevents the man-in-the-middle attacks. So you authenticate your peer to be sure it's really them you're talking to and nobody else. And another point where I don't have a picture for because it's a little difficult to explain is forward secrecy. It's also a neat crypto property, which means that when your keys get compromised, your encryption keys, at a later point, and your adversary, which is like the bad guy who's snooping on the traffic, and the adversary is recording all the encrypted communication for all this time, hoping maybe in the future he can decrypt it. Forward secrecy means even if he gets your key today, he cannot read what you wrote yesterday. Because each communication session has a session key which is derived from your other keys, but you cannot retroactively compute this key. So the past communication stays secure. So today we have this, and it's easy thing to do nowadays. We have the technology now. So also this is what we want when we look at messengers. And another point is what many people unfortunately still forget is that it needs to be free software, like software libre. Yeah? Because the freedoms that software freedom gives us are also important for security and of course for our daily lives. One example, even if the software does end-to-end encryption, if it's non-free software and nobody can inspect the source code and make sure it actually only does what it does, it's very easy for it to sneak your unencrypted contents out without you noticing, for example, or weaken the encryption in a subtle way so the skilled attacker can break it. So it needs to be free software, not only for security purposes, but also because we need to be in control of the technology that we use. So let's look at some popular examples. Who is using this? It's half of the people in the room. Yeah, so this is Telegram. The client program that you run on your phone is free software. The server is not. And even the client program, some people maintaining a free version because the official version is not free and has lots of tracking options in it. And it supports end-to-end encryption with forward secrecy, but you need to activate it. And most people don't. So all your chats are only transport encrypted and stored for a long time in clear text in the servers of Telegram, where whoever could maybe get them. And also the encryption they use is not really standardized. It's some strange homebrew stuff. And usually with encryption, the golden rule there is don't do it yourself. Because almost nobody on the world knows how to do this properly. So use something that is proven to work by a big community of researchers and scientists and hackers to be basically unbreakable, or at least we don't know how to break it. But this hasn't had enough review. So I would not trust that. So the other, who knows this? Yeah, that's just a handful of people. Who's using this? There's actually just one person in the room. So this is Signal. Signal is actually what you should use at the moment. Because it is free software, the server is also free software, and it has the best encryption technology today. The encryption technology is so good that this is what Facebook uses now and which is what Google uses now also. The creator of Signal, Moxie Marlinspike, came up with this with help of a few other people, and it's the Signal protocol, which was formerly called Axolotl. So it's neat because the encryption gets out of your way. You don't see it. And it works, and it's nice. It supports multiple devices. It also works when you are offline. And you essentially don't see it, and you cannot switch it off. It's just there. And it works, and it's so far known to be secure. Edward Snowden is recommending this as well. Well, for the free software lovers here, there's a problem that it doesn't work really with fully free phones because it uses Google Cloud Messaging, and there has been lots of controversy about this, but at the moment you can still use it with a fully free phone. There's Libre Signal, and maybe if somebody does the work, the normal Signal will also one day work with fully free phones, hopefully. So, who uses that? Yeah, that's WhatsApp, and that's what basically everybody uses in Brazil. And it's not that bad. WhatsApp also has adopted as the first big messenger the same security cryptography technology that Signal is also using. So it's basically the same thing. It supports also the group chats that are encrypted, and it's very neat. The only problem with WhatsApp is it's not free software. So you don't know what it does. And you cannot change it to do things you want it to do. You cannot remove bad things it might be doing. So I don't use it. but it's difficult because everybody else does. So this is the networking effect where they suck you in. But the good thing is it's easy to switch, right? Like yesterday I talked to somebody who was using 6 different messengers on their phone. Like who's using more than 6 messengers? Okay, thankfully nobody. But it's awesome that like WhatsApp, which is by far the largest messenger, adopted end-to-end encryption by default now, and you cannot switch it off. But there's problems, for example. You should check your security settings, because what happens if somebody gets a new phone? The encryption keys change. And by default, last time I checked, you don't get a warning about this. And even if you do, like most people say, ooh, what is this? Okay. And don't bother. But this could actually be a sign for a man-in-the-middle attack. Like this could be somebody else changing, like creating new keys for this person by, for example, intercepting the SMS, which is quite easy with SS7 network attacks. The same applies to the others that authenticate people by SMS. Yeah, it's actually not that secure. And if you're a high-value target, you can completely forget that. So, but I don't want to go through all the various messengers because there's so many. And like other people have been saying this, and I say it as well, like don't do a new messenger until it's really different, because there's too many. If you use something else, and if you want to look like how it fares in terms of security and how free it actually is, like the EFF has done an awesome job to create a secure messaging scorecard. And you can get that at eff.org/secure-messaging-scorecard. So I don't want to talk more about this. Just check out that page. So let's look at the architectures of all that messengers that we have seen before, because they basically look like this. So you have like it's a centralized system. You have like a giant server or like multiple servers, but essentially it's like one infrastructure that everybody has to connect to. So when you talk to somebody, you need to go through that point, which is bad for a couple of reasons. So one is, it doesn't happen all that often, but it happens. The service can actually go down due to technical problems. It even happens to Facebook once in a while. And when this one central service goes down, everybody's quiet. You cannot talk anymore to your friends, which is bad. Another thing that you are here in Brazil probably well aware of, governments also sometimes like to shut down stuff. And that is very easy when you have a centralized service. And I don't know if you have read the news, but just yesterday there was a attempted military coup in Turkey. And there as well, they're blocking certain social media sites, which is too easy when it's centralized. But it's not only this problem, like that it's not really reliable when you have everything in a single point of failure. There's also a question of control, because this company controls this one infrastructure. It's not your infrastructure to play with, it's theirs, and you are a guest there. And they might decide at any time to kick you out. And it happens a lot. Like I know a couple of people who have had their Twitter accounts blocked, who had their Facebook accounts blocked, and Facebook even in their official help center like has a page about this. Like, what do I do? Oh, what do? You can file an appeal and beg Facebook to give your account back. But that's not good enough. Like, we don't want to be guests in somebody else's backyard and somebody else's big shopping mall where we can be all consumers. We want to communicate freely with each other without people to censor and restrict our communications. But there's one more problem, which is also when you have all your data there in this one point, and all the metadata as well, who communicates with who, how much. Like it's a big target. It's a big juicy target for skilled adversaries to dig into there and get this data out. So that's why very early, like the internet hasn't always been looking like this. Actually, it was much more decentralized in the beginning. And there is all technologies which have architectures which look much more like this. So you can see the change is that you have now much more servers which talk to each other, have connections. And the most simple example for this is email, right? So even if Gmail decides to block you, you can still have an email account in another person's server and still take part in email. Nobody can exclude you from email, which is a lot better. And also companies, private persons, institutions, universities can have their own email servers in a big federated network that all talk and work interoperably with each other. So when you look at freedom and control, like and also censorship resistance, this is a much better architecture. It's also a lot harder to block. Like if somebody blocks one or two of our servers, all the others will still continue to work. So this is like more the direction where we want to have our technology move back to, because this is where it came from. And when we're looking at messaging, there's XMPP and Jabber. I don't know, who has heard of that? It's more people than have heard of Signal. So for all the others that don't know it, it's basically like email, but for chat. So you start an app like this one, Conversations, which I can only recommend. I think it only works on Android phones. You just open the app, and in this case, they just create an account on their own server for you, but you can also switch to any other server that you would like to, because there's many. You can also have your own. Like I have my own Jabber server. And then you can just use this to communicate in a federated architecture like email. And it's very nice and easy, and basically now it works just as well as the others, but historically it didn't have any encryption. Like today still the communication between some of the servers is not encrypted, but at least transport encryption is enforced, but end-to-end encryption had to be like put on top later. And this is OTR, like off-the-record messaging, which was nice when it came out, but it has, in today's world, some problems. Like it doesn't work when you're not online at the same time. Like you need to agree on a key, basically, while you're online. You need to have communication going on. And today we have multiple devices that you like to chat on, like switch from our computer, from our laptop to our phone. OTR doesn't really support this nicely. So that's why people have started to implement the Signal protocol for XMPP under the name OMIMO. And Conversations does support it, and Gadget on the desktop supports it, but none of the others yet. But I think there's more work will be done in this area, and then you can use the top-notch security as well with XMPP. But unfortunately also with Conversations, because so many people don't support it, it's not activated by default, so it's very easy to shoot yourself in the foot. But if you go a little bit away from the pure messaging software, there's also social networks. Like there have been great attempts at doing social networks that, of course, cannot do centralized again. Like they need to be federated. Like you don't want your social network in one point, which is great, and it has been a good improvement. Like, and I'm supporting these efforts as well. But there's still some problems with them, because for social media, if you share stuff, now it is not only stored in one server, but in many others, who you don't know who is running those servers. And now you also have like metadata distributed over more other servers, more other connections. But control-wise, nobody can exclude you anymore, and you're free to open up your own stuff. That's great. But security-wise, it introduces more problems, unfortunately. So with the secure messengers, like many people insisting now end-to-end encryption has to be there because it's so easy to do, and there's no reason anymore for you not to do it. But still, we're not doing the same with our social networks. I think we should. But what we should also be doing is think again about whether this architecture is still where we want to stop, if we maybe shouldn't move more to an architecture that looks like this. Like we had the centralized one with the federated one, and now we have like peer-to-peer. Like this is completely decentralized. There is no servers anymore. Nobody needs to run a server, which is the best thing, I think, because it's the hardest to block, the hardest to censor, and if you do it right, like it depends on how you make the communication within this network, but you can also make a communication that there is actually no metadata for people to exploit. And let's talk a bit more about the metadata, because many people don't realize, like, sounds like so abstract. It's metadata. It's just it's not real data even. Like, why is it dangerous? So look at this sympathetic guy. Like this is a former director of the Central Intelligence Agency and the NSA. And we have this guy on video where he is saying, we kill people based on metadata. Like they're actually flying drones, dropping bombs on people because they have the metadata. So I tried to find a visualization, like how I can make this like a little more visual for you guys, and I just found this. So the intelligence community has tools that do this automatically. They create social graphs where they can see into certain groups of people, like how do they communicate, what is their communication structure, who communicates with whom how much, and who are the people where most of the communication lines go into. Like this is the bigger balls there in the picture. And this is the information that is even most interesting, because just imagine you have a dissident group that is like, I don't know, trying to plot against your government or is talking too much about human rights maybe. And you want to get rid of those people because they're endangering your leadership, your government maybe. So what you do is you just look into the social graph and see where is the key people in this group. Who are the people that all the others rely on? Who are the leaders? You find them easily, you know where they are, and you just let them disappear, for example. And that's pretty dangerous. So we made so much progress with our technology that we should also solve this problem. So let's revisit the 4 criteria that I had to evaluate communication applications. So end-to-end encryption, authentication, forward secrecy, and free software. We have this now. There is programs that do this. So let's raise the bar to the next level and let's try to get there. And I already said it, but let me summarize. So we need tools that don't leave traces of metadata around. Yeah, so nobody needs to know who are we communicating with and how much and when, because you can draw conclusions from this. You can, when somebody calls, like we have data retention in Germany, and there have been many examples, and even politicians that voluntarily let their data be recorded, and to make clear to people what it actually means. And even one phone call can give up information about you. Like if you call a doctor, and then later you go there, and it's a doctor that is specialized for cancer. Like they can draw certain conclusions from this. Or you call a restaurant, and later they see your GPS signal moving there. And then they see somebody else's GPS signal moving there. Or you call somebody else after you call the restaurant. No, they can draw conclusions that you probably are going to meet with those people there. And the other point is, I call it censorship resistant. So it should be impossible, ideally, to block the system. Like the government should have no ways to interrupt our communication. And we should build our technology in a way that it doesn't. Of course, it would be better if we change our governments so they don't do this kind of stuff. But until we are not there, we can also build technology. Because most people here have something to technology, so let's build technology that solves this problem on the technical side while we are still working on the political side. So the application I am at the moment working on, which has some answers to those problems, is called Briar. Like, unfortunately, it's not ready yet, but it has been in development since late 2012 already. Like by people who know what they're doing and who have been also involved in other areas of peer-to-peer software. But if you like, you can get an unofficial test version from me after the presentation outside, if you really just want to test it. So let's look at how it looks like at the moment. So there's an Android app, and if you open the app, normally you need to provide a password. So that is because all the data is stored on the app, including your cryptographic keys, and the full disk encryption on Android is not yet good enough that we could trust it. And it's also not on by default. So most people don't have actually full disk encryption on Android. So we need to introduce another layer to secure the data at rest. Like when you get arrested, for example, no? They cannot just take your phone and have all the messages and all the crypto keys and even can impose to be you. Like, that's pretty dangerous. So we don't want that, and that's why there's a password. And like I said, the architecture of Briar is this. There's no servers. And that also means all the data is stored on the people's devices and only shared with others when you actually want to share it. And then it's stored on other people's devices. But there's no central point where you could take it down, where you can say, you need to remove this information from the internet, because how do you do this? You don't even know where it is. it's on everybody's device, and people can share it with everybody else if they choose to. So how do you make the connection? Like, how do you add people? Like, as I mentioned, there's the problem of authentication. You need to make sure it's actually the person you're talking to. Some apps, like I talked about before, offer this as a thing you can do afterwards. Like, you can meet up and you can scan a QR code to make sure this matches actually what is in your phone, what your phone thinks. So we do this in the very beginning. So when you make a connection, you need to meet somebody personally, and you need to scan their QR code. So then you exchange the secret keys, which are only stored on your phone, and because you have met the person, and because it's very difficult for an attacker to get in between the scanning process, you can be reasonably sure that this person is actually the one you think you're talking to later on, even when you're not close anymore. So after you edit a contact, you have a contact list, and it's just a regular Android app, essentially. And you can see if they're online or not. You can see how many unread messages you have. And here in this screenshot, you see two identities. So Briar also supports different identities. So it can be one identity to this group of people and another identity to this group of people. But actually, for the first release, we have decided to not support this, to not do this anymore, because it's too complicated for now. But later, we want to bring it back. All the technology supports it, but there are some tricky cases we don't want to solve right now. So let's look at the general architecture of how it works. So it's basically three parts. The top part is like what the user sees. This is an Android app and a desktop program. The desktop program has been started, but it's not really ready. That's why like it's a little translucent here. Like, all the translucent parts are the parts that are not there yet, but planned. So then in the bottom, you have the message synchronization layer, which we call Bramble, and which we plan on releasing as a separate library, so people can also build other applications on top of that. And here in the middle, you have the applications, which is like a plugin, like we call it the client. And the white ones are the ones we have ready. But in a way, it's just showcases to show you what the technology can actually do. So before I'm going deeper into this, I show you like the use cases that we have implemented already and show them how they work. So one of these plugins or clients, how they work is they just have a channel to make a communication, and they have messages that they can send through this channel. And they don't need to know anything about the crypto and that stuff. They just have like contacts, and that they can decide to share this communication channel with, and they can just put messages inside. And the most simple case is the case of private messages. So when Nerdson adds Beta Bitsy on his phone, automatically this communication channel will be created. And when they send a private message, it's just a normal message going through this channel and arriving there. And it's automatically created, and they cannot share it with anybody. So it's just them. It's like a private message. When they talk to each other, they just use this. This is the most simple case. And in the app itself, it looks like this. So messages back and forth. And a more complicated case is forums. In forums, you can share this communication channel with as many people as you like. So you can create a forum, and it's just you inside, you haven't shared it with anybody. Then you add more contacts, and you share it with them. You add another contact, you also share it with them. And they can share it with others. So it like grows exponentially through the network. And when somebody puts a message inside, all the others get it. And it's not created automatically. You actively have to do this, and you can create as many as you want as well. Like, for example, you can have a forum with only 3 of your friends where you post stuff. Nobody else has it. So nobody else knows this data even exists. Nobody even knows that you are communicating with each other. And I'll show you in a bit how that works. So, but first, this is how the UI, the user interface of the forums look like. So that you can have threaded discussions. You can collapse the discussion trees, a little bit like on Reddit. Another feature is the blogs, which are also a bit different. Because at the moment, the blocks are also automatically created with you, and they're automatically shared with all your contacts. So it's in a way like a Facebook feed or like Twitter or Tumblr. So you can also see here, they cannot put stuff inside, they just get stuff out. And so this is a one-way thing. So Nerdson's blog is this. And when Nerdson blocks something, his contacts see it in their feed. And this looks like that. So it's just a feed, you can scroll down and see all the messages that your friends posted. Later, maybe we will also allow you to create additional blogs and share blogs with other people. So back to the pipe, because we all know the internet is just a series of pipes, right? So there is some other clients which you saw on the diagram which also use these channels to facilitate communication, but this is what you don't see this. For example, when you share a forum with somebody, you also have something like a private message channel that you never see in the UI, but which exchanges information about the forum that you're sharing and makes sure it's actually this forum and nobody can tamper with this, and allows you to reply to the invitation, say, yes, I want this forum, or no, I don't want it. So this is not only to create visible features, but also like a program communication, remote procedure calls if you want. You could also do with this. We have another feature. This is here the introduction client, which means you met some people in person, added them as contacts to a list, but you cannot necessarily meet all the people in person. So we made it a little easier by allowing introductions. So you know two people and you think they should be introduced with each other. So you do the introduction. This is not as secure because maybe you cannot actually trust the friend who did the introduction and who is introducing you actually to a man in the middle and you think you're talking to the other person. But we assume that our threat model is that the adversary has limited capabilities to convince your friends to be bad guys. So when you trust your friends enough, you can use this and also rely on this to get more contacts in the app. The transport client, this now plays into this lower thing that I haven't talked about yet. Because in Briar, there is multiple ways your data can get transported to other people. So I mentioned that it doesn't leave traces of metadata. So it does this by not using the internet directly. Like you notice that here is no internet in the bottom. This is because it uses the internet only through the Tor network. Like, who knows what is Tor? That is more than half, which is good. So I try to make an easy explanation here. Like this cloudy thing is like the Tor network, and you have like various nodes and relays and exit nodes and stuff like this in the Tor network. And who knows what is a hidden service? An onion service? Listen to more people. It's basically the same. Like for those who don't know, you can create a service in the Tor network which is addressable for other people in the Tor network. It has an address, so you can find it. But you don't know what IP address it has. You don't know where it is. You don't know who's running it necessarily. So like many like drug marketplaces in the darknet are using this because it's difficult for the police to find out who is behind it. And they need to make some mistakes to be able to be caught. So Briar uses Tor hidden services on your phone. It creates a Tor hidden service which connects to the Tor network, and this is how people talk to each other. So there's never through the internet, never a direct connection between Alice and Bob. It always goes through the Tor network, through at least 3 other computers. So even if you have an adversary that is looking at your communication, even looks by chance also at the communication of the other people that are part of the Tor network that you don't know. These people don't need to run Briar. It's just some people running Tor relays on the internet. And they relay your traffic through 3 hops, so the adversary cannot know who this actually is reaching to. Like there have been some attacks, but it's like the best anonymization network that we have today. So that's why we are using it. I personally think the NSA specifically, if this is your adversary, like you have lost anyway, and they might have capability to de-anonymize some of the Tor traffic, but if they do, probably only some, and I think no other adversary has it. So Tor is really the best thing at the moment. But besides Tor, there's also LAN and Bluetooth, and there's also like direct Wi-Fi, for example, which is not implemented at the moment, but could be. And the desktop client also has another transport, which I don't have there, which is this transport. So you can actually plug an SD card in your computer, and your computer will put the messages on the SD card. You can put it to a pigeon, the pigeon flies to your friend, he puts the SD card in his computer and gets the messages. So it's also a delay-tolerant network, because you don't know, like maybe some people are really off the grid for some time, and they come back, then all the messages will be synchronized to them. But there's other use cases, like for example, natural catastrophes. Like this is something we're also strongly thinking about, because in a case like this, the public infrastructure breaks down, and you still need to organize help. Like the aid workers that are streaming in from all over the place, like they can of course start building infrastructure, because like they can bring equipment, but it takes time. They need to help now. So the idea is that you can use Briar to communicate in a case like this through Wi-Fi and through Bluetooth, let the information flow, and maybe also build other applications on top of the technology that we provide as a dedicated library, like all the message synchronization stuff. And there you don't care so much maybe about the crypto properties it has. Like it's all end-to-end encrypted. I haven't mentioned that, but I think it's obvious. So there could be a system, like somebody could build that allows the people to say what is actually needed. Do we need food? Do we need water? Do we need warm blankets? Like what is it? And then have this information automatically flowing through the network, also arriving at the aid workers' place, and they can act on it. And they can even maybe know where it is, where we need the most stuff, where is the most help needed at the moment. All even without the internet working. And another area where this could be nice is a place like this. So I don't know how many of you have heard about this, but Anatel is the national communication authority here, has actually authorized Brazil to block the internet completely during the Olympics. And this is really bad. And like also in Germany, and I know in the United States, politicians always think about a quick kill switch. We need a kill switch for the internet. Like, thankfully, so far, they have understood that it is not a good idea at all to turn off the internet for people. But there's other countries that haven't understood that. Brazil is one of them. But I also frequently hear about even countries turning off the internet for 1 week just because they have a national test for their students and the students should not cheat. So they turn off the internet because of this. And this is impossible. So we need a technology, and I hope Briar can be a solution for this, that even works when the government does this. So imagine you are in a demonstration like this, and you're demonstrating against the Olympics here in Brazil, and the government actually flips the kill switch. Internet is down completely. Like your mobile phones don't work anymore. So if you're in a demonstration and you have like a group, then within this group in Briar, it actually works very similar to a mesh network within this group, not outside, because the people outside don't know who you are and who are your friends. Yeah? Like that's the metadata that they should not have. But within your group, if the people within the group have some sort of a connection with each other, the messages will flow. So even if there's the people in the back and you have sent a message in the front, it will make its way through other people's phones to your phone, which is amazing. And also, like, if you're like split and you're too far away and you don't have the connection, and one group here communicates and one group here communicates, later when they meet or when there's one person moving more in the middle, making a connection for both groups, then suddenly all the old messages will also be synchronized and you get them. So we don't really have an official mission statement at the moment, but what we have like in our texts, what's most closest is this one. So our goal is to enable people in any country to create safe spaces where they can debate any topic, plan events, and organize social movements. So that's what we want to do. And I put some emphasis in there, which I personally think is important. So enabling and creating safe spaces, because the places we have at the moment are not safe enough. So that's why we want to make them safer. If you want to know more, this is the internet address of the project. And now I'm at the end of my talk. Thank you very much for your attention, and we have some time for questions. Thank you. So, like, we have this app, but it's unfortunately not yet free software, but you can use it to make questions. So, no questions. That's strange. Oh, there's one question. Scream? Okay, the question is, how does it work with Tor? Because like Tor is complicated technology, installing it is difficult, you might need root and stuff like this. So yeah, I should have mentioned that, thank you for the question. Tor, we use Tor, but you will not notice that you use Tor. So the people who afterwards like get a test copy from me, they will see you just install it like a regular app, but Tor is inside. And Tor will work inside without you noticing anything, and you don't need root. It just works. It's just there. It's very nice. And I'm happy to try it out with people here, because we're still testing it. Like, we need some more test data to see like where are the rough edges to fix it before we make the final release. When will it go live? So we plan to release it before the end of the year. But, you know, software projects tend to be late, so I don't want to promise too much. But maybe we will even do a public beta before that. How can you be notified about that happening? I think on the website there is actually like something like, I want to be notified. And you just put your email address in there, and then, like, we don't send spam and lots of messages. I think you will only get one when it comes out. Which language is that written in? Which computer programming language? So, since it's an Android app, it's written in Java. The library is also a Java library, and the desktop program will also be in Java, just also for the cause that it can use the same library, and that it can run on all the platforms that you have. But there is, of course, parts which are not Java, like the Tor stuff. But if somebody would like to have another implementation in another language, like, we would definitely support this. Like, we would like to see this also for running on iPhone devices. How many people are working in the project right now? So we have 4 programmers and 1 graphic designer, and a handful of volunteers which from time to time contribute. The release will be worldwide, yes. It will also work in Brazil, yes. Like, we will put a version into the F-Droid store, like, which is a free app store for Android, and it will also be in the official Play Store as well. But now the app is working. Hi there, actually I have many questions, but let's be simple. Is your intention to create a messaging app where people talk everyday chats? Yes, that as well, definitely. Like, but I know that, like, I talked about this guy who has 6 apps already. So it's meant for everyday usage, but of course the focus is for people who have like elevated needs for security, like journalists, for example. But the intention is that it works just as well as WhatsApp. Can we use the radio amateur infrastructure? Possibly. The transport that I mentioned, they have a plug-in architecture, and if you have like a simplex or a duplex connection that can send bytes over this, it will work. So it should work. Like, I'm not a radio amateur specialist, but I think you can also send digital information over the radio signal. So why not? Yes, please do it. So, more questions? You had one, yes. So the question is could it be an attack to flood your cell phone with lots of messages so that you run out of storage? So yes, this is an attack, and we've been thinking about this. But first, it's not as bad as you might think, because it's not like the other peer-to-peer technology works a lot with distributed hash tables, where you just call out in the network and say, I have a message for this hash, and please relay it if you know where it is. So your phone is relaying other people's messages a lot, and we don't do this. It's also very bad for battery, because your phone always has to be active and do stuff. We only communicate with your friends. So you need to have a malicious friend. And one countermeasure could be that we show you, like, look, this friend just has sent you like lots of messages. We have stopped this automatically. You're at the moment not getting any more messages from this guy. What do you want to do? Yeah, that would be very simple. Well, that's good thinking. Like, we need people like that think, okay, how can I break this? So no more questions in the app. And like, I don't know who asked the question about everyday chats. Like, be welcome, meet me after the Fisl. I will be here like until the end of the day as well. Just catch me and we can add each other. Okay, then, thank you very much for your attention. You're also welcome to catch me after the talk if you have more questions you want to ask privately. Thank you very much for being here.